Hi again. For this video, we are still going to try to solve some quadratics and then translate it into trig. So we have 2x squared is equal to 8. Notice the difference for these equations is that we do not have an x term. So the method for solving these is typically isolate the squared term and then take the square root. So solve using square roots. So first, we do need to divide by 2, get the x squared term by itself, and then we're going to take the square root of both sides. And the only thing that we're really going to need to remember is the possibility that there are two solutions. So, in the x squared is equal to 4, that could be 2 squared equals 4. It could be negative 2 squared equals 4. So we want to keep both solutions there. All right, this one, the x squared term is already solved for, so just take the square root of both sides. And we're going to get x is equal to plus or minus the square root of a third. And we probably want to, for trig's sake, break this down into the square root of 1 over the square root of 3, which is plus or minus 1 over root 3. Okay. We may be more familiar with this as plus or minus square root 3 over 3 if you rationalize the denominator by multiplying by root 3 over root 3. Okay, this is going to end up being a trig value that we know, so it's going to help later. All right, now let's see how this works for trig. Pretty straightforward. I think the key is just remembering that there's going to be more solutions than you're expecting, perhaps. All right, so for here, we're going to divide both sides by the 2 to get the cosecant squared theta by itself, and that's equal to 4. We're going to take the square root of both sides. So we get the cosecant of theta is equal to plus or minus 2. All right, so we've done cosecant, that is 1 over sine. So that's the same as the sine of theta equaling to plus or minus a half. Okay, so in other words, we're talking about all 4 quadrants when we're talking about 0 to 2 pi. So let's see. I even drew this one a little bit more accurately because sine being 1/2 means the opposite side is the small side. So here we are, all 4 quadrants, so that we're positive and negative a half. So the reference angle would be 30 or pi over 6. So theta is equal to pi over 6. And then I could just list all 4 for the solutions in 0 to 2 pi. So that's pi over 6, 5 pi over 6, 7 pi over 6, and 1 back from 12, 11 pi over 6. So those are my 4 solutions in 0 to 2 pi. And then if I want the general solution, I really just need 2 pieces. I need the one that's in quad 1, and I'll just add pi k to that, because notice that I can get to here by adding pi, right over here. And then I can do the one in quadrant 2 and get to quadrant 4 by adding pi. So I would go also 5 pi over 6 plus pi k. I don't have to list all 4 because I can get all of them with that 2. All right, let's do one more of those. So tangent squared theta is equal to a third. The squared is already isolated, so just take the square root of both sides. So you get the tangent of theta is equal to plus or minus square root a third. Okay, we already talked above about how that would be equal to 1 over root 3 or root 3 over 3. Okay. 1 over root 3 might be the most useful for some of you if you are kind of drawing triangles for each thing. We're in all 4 quadrants again. So what we're talking about for tangent, if it's 1 over root 3, is opposite is 1 and adjacent is root 3, right? So that, if you're struggling with which reference angle goes with which for tangent, that might be the easiest way to look at it, 1 over root 3. But in any case, you can see that that's the smaller opposite, so that's reference of 30 degrees. So we have the same answers actually as right here. So we should go into each quadrant because we want tangent to be positive, 1 and 3, and negative in 2 and 4. So our answers are actually the same as the last problem. That's just a total coincidence. It just kind of happens a lot because there's not a lot of choices for the unit circle, right? So just kind of writing everything down. Even these would be the same. So pi over 6 plus pi k and 5 pi over 6 plus pi k. Okay. Now you guys try those next two on your own and make sure you got it.